Greetings! Today we'll talk about NFTables, the successor of IPTables and a widely spread Linux firewall. It can be used as host firewall or even as network firewall. What will we talk about? First, I'll give you a little bit of an overview over the NFTables project, where I can find the documentation and so on. And after that, I'll show you our test box, our test firewall, and we'll go into the basics of configuration, management, handling, however you want to call it. Before we start, I'll introduce myself. My name is Rad, and I'm located in the southeast of Austria and have around a decade of practical experience as IT systems administrator with a focus on network and Linux administration. Alright, let's get into it. NFTables is developed by the netfilter.org organization, which also has developed IPTables, so it really is the successor of IPTables, not some external tool that only claims to be the successor. At netfilter.org projects NFTables, you can find a pretty good overview of what the project is about, and also you can find the links to the source code here, because of course it's open source. At wiki.nftables.org you can find the documentation. The documentation is pretty good in my practical experience. I would guess around 99.5% of all practical use cases can or are covered in this documentation. Sometimes you'll need to search a little, but it's in there. For starters, for starters or for reference, I would recommend the 10-minute reference, quick reference. I've opened it here already. It's pretty good because it contains most statements you will use in day-to-day configuration work. Let's look at an example. You can find the command, how you edit it using the CLI, and also the parameters that it takes. If you don't have practical experience using NFTables, I would recommend you to open this reference guide now, because when we dive into the basics of the NFTables configuration, I cannot go into detail about every option. You can pause the video, research, look it up, and come back. Yeah. Alright, so let's switch to the CLI. Alrighty, here we are on the shell. First of all, we are working on Debian 12, so keep in mind, especially for the service-related handling and configuration, it might be different if you're on another distribution, on a non-Debian based distribution. Alright, let's check the rules of NFTables. We can get it using the nft list rule set command. So there's nothing there. Yeah, that's the case if NFTables has not been loaded. In our case, we can use the systemd service to load and auto-load the configuration on startup. So let's start the NFTables service and also enable it so it will get loaded on startup. Let's check out that service. Yeah, that's the service. You can also look into that service file, check out what it does. It's basically just loading the default configuration. Nothing fancy, and on stop it will flush the configuration, so all rules get removed. Now, if we run a NFT list rule set, NFT rule set, God. It looks like this. This is basically pretty much the same as in the default configuration file. Of course, if you have multiple configuration files later on, the output of list rule set will be the merged configuration. Yeah. Alright. You can validate your configuration using the NFT command with flags cf and provide your config file. If we have some bad configuration in there, we'll get an error. We will also get an error if we use configuration that refers to a kernel module that has not been loaded. This is especially good to know as the error is not that clear. It's pretty much a syntax error, but the only problem is that you haven't loaded the kernel module. NFTables has many or some kernel modules. It depends on your distribution and your distribution release. About what kernel modules are loaded by default. If you want to use some advanced configuration using quotas or sockets, dproxy or something like that, you might need to load one of these kernel modules using modprobe, and you might also need to make that persistent. Yeah. Then let's look into the error handling of NFTables. As we have seen, the configuration now is working again because we don't have an error in our config. What will happen with the service if we have an invalid configuration? You can test it. Let's reload the service. The service has failed, yeah, of course. Let's check out what it says. Yeah, exactly the same as we have seen on the CLI. If we check the current rules, they are still there. This is because we have executed a reload. If we execute a restart, let's test it, restart, we will run into an issue. Yeah, service has failed again, yeah, but the rule set is gone. This is because, as we have seen in the service, the stop flushes the rule set and the restart executes a stop and a start after that. So it flushes the rule set but cannot load it again. That may not be the behavior you want. Of course, you could argue, why use a restart? Yeah, of course. But I personally like to be a little safer and like these errors to be handled without my Firewall rule set being completely flushed and not being active. you can use a systemd override to handle this kind of errors. Let's create it. NFTables service D, and I've prepared the override. I like the systemd system path very much. Okay. Okay, what do we have here? We have basically three statements, so to say. The bottom one, the exec stop, will save us in case of invalid config when restarting the service. It basically removes the default behavior of exec stop, creates a config check before flashing the rule set. So if the config is invalid, the rules will not be flashed. We'll see that when we are done discussing this config file. And the exec start pre and reload are pretty much optional. I personally like it just because I feel a little safer if a check command fails instead of a config load command. Yeah, it's a personal opinion. Alright, we have added this systemd override. Let's load it and check the status of NFTables. I'll just quickly flush this error so we can see the behavior. Let's comment out this config error, restart the service. So now it's up and running. We can see on the start it executes a config check, and after that it loads the configuration. We can also reload, systemctl reload NFTables, and we will also see the reload config check and the reload. Now, if we invalidate the configuration and perform the reload, it is active because the reload failed on the config check. And if we check our rules, list rules set, they are still loaded. Of course, it was a reload. Now, if we restart NFTables, it also failed, and the rules are still there. We can see the behavior using journalctl, and here it is. It's stopping NFTables and it failed the config validation. After the config validation failed, it exits the stop queue, so to say. It will not execute the next stop command. So the config flush is not executed, and this is, in my opinion, pretty nice config handling. Pretty nice tweak, so to say. Yeah. If you have existing IPTables configuration, you can translate it to NFTables configuration. You can use the IPTables translate. No, sorry. How did it? Tables, IPTables restart translate. Sorry. You can dump the IPTables configuration of an existing system using the IPTables save command, so you can save it to a config file, and after that you can use the restore translate command and target that saved IPTables configuration to translate it to NFTables. You see, these are NFTables commands. They are not in the config file syntax, but it's better than nothing. This also means, as IPTables is pretty much using NFTables in the background, if you are searching for some very specific edge case, you can search online for solutions for this edge case using IPTables. There are around 1,000 times more articles and so on online that discuss IPTables instead of NFTables, because NFTables is still young, so to say. It's I don't have it on top of my head, but around 10 to 15 years old. So yeah, because I'm mentioning this because I had this exact use case for something like that, a very specific use case. Yeah. All right. Now we can start with the configuration. All right. Before we're getting started, just a little warning. We'll get to know many little features and topics regarding the basic NFTables and netfit configuration. So if you need to know a little more about it, just pause the video, check out the NFTables wiki, the quick reference guide, and come back later on. Yeah. Now, where do we start? I will create a config directory. In my practical experience, when the rule sets get a little bit more complicated, I like to use multiple config files. So I create the NFTables D directory and copy the NFTables conf file to the NFTables D directory just as a starting point, and then edit the actual main file, remove the table, keep the flush rule set as mentioned before, and after that we can create an include. So all conf files inside the NFTables D directory will be included. We can also check out the permissions of the NFTables. Sorry, let's say grab NFT of the NFTables directory, and yeah, we can restrict those. So make it so only root users in the root group can read the files, because our rule sets shouldn't be public or not readable by default service users. Okay, now let's edit the switch to the directory and edit or rename the config to testconf and edit it. We can remove the flush rule set, as we are flushing the rule set in the main config file, but we will keep the table. So let's reload the config and check out the rule set. It's still here, so that works. Now, for starting, I would always define the default policy here. Yeah, let's set it to accept first. Policy drop. We can drop forwarded traffic as we are no router. We don't forward traffic here, and we will accept outgoing traffic just because it's a little easier to work with for now. Reload. Okay. We can check these policies here. So all traffic that is not matched by any other rule will hit the default policy. Now, let's create two variables, two NFTables variables, and let's create our first rule. Now, I'm defining a network and a list of ports. So with those curly brackets you can define a set, it's called in NFTables. You can think of it as a list. You can also define a list of networks and so on. There are many nice features to work with. Okay, let's create a default management rule so I do not block myself. So we say TCP to the destination ports from the source net is accepted, and with the default policy drop we say everything else is dropped. Now reload. Let's check that we can SSH to the server and it works. Okay, this rule works. Now, what happens to the default deny packets? How do we get to know what falls into this default deny rule set? We can log those packets. So if when we add a log prefix to the last line of the chain, it matches all packets that will hit the default policy. So let's just add this line, reload, and sorry, NFTables. I don't think I can see here. Let's just follow with no scope. Let's try to connect to port 23. That should run into the default deny, and we see NFT drop default input. Exactly what we configured. I personally would recommend you to use a good log prefix and start all log prefixes with the same syntax. So I use the NFT prefix and after that drop or allow, for example. So in that case you can easily filter your logs on these conditions. Also, if you send them to some log system, central log server, you can parse those parts of the message and make nice statistics and so on, alerts, whatever. As you have seen, the NFTables logs are logged to kernel, or to the kernel application, so they are not logged as NFTables. So it's good to have them with some prefix to filter them out from the kernel logs. You can also use rsyslog and logrotate to redirect those kernel logs to a log file. So you have a real NFTables log file, because in Debian 12 and so on, you don't have that by default. I will showcase that in another video, how to do that, how to manage NFTables logs. Yeah. Okay. Where are we? Now, you can match interfaces using the keywords ifName and oifName, or you use it short oif and eif, I believe, I think. Okay, in this case we allow local traffic, so loopback traffic. That's pretty handy to have, I would say. Okay, next up we will check out the connection tracking and start with dropping connections of the state invalid. So, for example, packages of closed TCP sessions fall into that category. We can also use the connection tracking, the CT, to log new connections to a port. So let's unwrap what's in there. We have CT state new, so only new sessions. If they target our management port from the management net, log it as NFT allow management. So you can append log prefix to any rule, basically. But if you have TCP traffic, it makes sense to only log packages of new sessions, because else your log system will be completely overloaded, as every packet will produce some I/O. Not that nice. Okay, so far so good. We can test that. Just let's connect to SSH, and we see NFTables allow management. Yeah. Okay, and last one for the connection tracking is allowing existing sessions, so existing TCP sessions. This is very important, as you will run into problems if you do not allow existing sessions. Okay, our rule set is growing. Yes. You can also define rules for multiple protocols. So let's define a host DNS, and just to showcase it, we will add a rule that allows us to connect to the DNS server. As DNS can be UDP or TCP. We can use the meta L4 parameter or syntax to use a set of layer 4 protocols. when using this syntax, you need to add the th before the board. Don't know why, but that's how it is. Yeah, that's how you can use multiple protocols in one line. Okay, let's check out ICMP. Let's create a net private variable that might be handy for you too, and I have prepared a ICMP base that has the basic ICMP version 4 types listed. So we can accept ICMP for a complete net, or in that case the whole ICMP protocol is allowed, or we can also use only some base types, because sometimes you may also may only want to have the most basic types allowed. Yeah. Of course, there's IPv6 and ICMP. I'll add the types now, and it will get showcased later on. I see IPv6 has a little bit more in regard to ICMP, as ICMP is very important for the functionality of IPv6. But you can also use codes, ICMP codes, to allow ICMP connections. In that case, you would use the code parameter instead of the type. However, you need to do it or want to do it. Now, some drop rules. Wop, wop, wop. Just paste them in there. Format them a little for you. These are basic rules that you might want to add for existing TCP vulnerabilities, but this should showcase that you can drop specific packages and also lock them with a specific prefix. You can also, or should also, use a drop rule for Pogon networks. So non-internal, only internal networks, sorry, or not routed networks, better to say. If you have a device or a server that's running on the public internet. So if you have a public IP on the interfaces where you have your public IPs, you may want to drop connections to Pogon networks. In that case, IP destination address. Sorry, source address, not destination, as we don't want to get any of these OIF name public, whatever your output interface is called. OIF name public. If a packet goes out to the public interface and is not a public IP, then drop it. Something like that. I will comment it out as I'm working with private nets here. Alright, you can also jump in between chains. Let's add a chain first. No, let's add a variable first. So let's add the variable, and after that a chain. Let's assume we have some interfaces, some VPN interfaces on this server, and want to allow only those interfaces to access this network. You can use the if name with a wildcard to achieve this. So you can use the interface prefix VPN in this example, and match all interfaces that start with that prefix and jump to the other chain. This is pretty handy to have. In our case we won't need it, but I wanted to showcase it. We can also use this jumping to define basic input chains for IPv6 and IPv4 traffic. This can be nice to have if you have many roles and are running a tool stack system, because it makes it a little bit more transparent, and also the packets are pre-filtered, so they don't need to match IPv4 packets don't need to match any IPv6 rules, or even check if they match. Alright, we can use a meta protocol VMap for this setup. So we pull out the meta protocol, so the layer 3 protocol, and create a virtual map. We have the match IP, so IPv4 traffic jumps to the IPv4 chain, and IPv6 traffic jumps to the IPv6 chain. Let's check if the syntax works. Yes, looks good. Now list rule set. Now our rule set has already grown. Okay. Okay. Now, next on, we have source and destination NAT. Let's put that in here. And this here. Okay. Basically, you have to define the chains and create the hooks. in this form, this post routing is used for masquerading, so for outbound NAT. And these are destination NATs. So this is source NAT, these are for destination NATs. Output destination NAT would be for traffic that is originating from this exact box, and pre-routing destination NAT is for traffic that is forwarded through this box. So if we are a router or something like that. Yeah, these are just an example. Oh, some syntax. Oh, sorry, yeah. Did not configure. That variable. All right. Now, this is pretty much a good overview of the basic features of IPTables and the syntax. I personally would recommend to work with the configuration file directly instead of using the NFT CLI commands, as it's easier to work with and I think easier to understand what's going on, to have the logic links, so to say. It's also much easier to template if you're using some automation tools. Might be some of those out there. Okay, now two more good to have features. First, we will create a limit. A limit limits the traffic of a specific rule. So in this case, I would assume that we have a public device and we want to limit the ICMP traffic to this device so nobody can flood us. Okay, this would be something like that. Whoop. Let's add it to the drop rules up there. We can use the ICMP type echo request in this case. Let's only match ICMP echo, and log and drop if it's over the limit. So yeah, we see up here if it's over the limit of 20 packets per second. Of course, 20 packets per second isn't much for a productive system, but for a test system or something like that, it's okay. You could also exclude your own IPs from that limit, of course. And we could also use a limit on the default policy logs. Sorry. That would be here. Let's call it default input. And this could be handy if you have many board scans. Very aggressive board scans may create around 10,000 logs, drop logs per second, or something like that. You could handle it a little better, but in this case, you could at least limit the load on your I/O regarding your logs. We could test it. Yeah, it's a little hard to test for me now. that's how it works. And another good to have feature you might want to know about is, where do we put it? It's in the outbound destination, I believe. We can match rules on users. This can be done like this. Sorry, let's jump up here. I forgot to create a second variable. In this case, let's assume we have a transparent proxy running. We have some networks that are excluded from destination networks that are excluded from the proxying, and we have a user that actually runs the proxy service. So we can do work around a redirect loop. We can exclude this proxy user from the redirect. Can say in this case HTTP and S traffic if it's not targeting our excludes, and the user ID is proxy. On NFTables we can define the user ID or even the username. I personally like the username as it's nicer to work with and a little more transparent. A little bit more transparent. Yeah, it's reloaded, looks good. Yeah. Whoop, here we are. Let's give it another look. We have our limit, our running config, then we have our input, in this case some drops, security drops. After that we use jumps to split up our packets, the path the packets take. After that we allow management, we log management, and then we allow management. We allow the complete ICMP protocol on the local management network. Then we allow basic ICMP for all private networks. We allow related and established connections, limit the logging of default policy drops, and yeah, have the input VPN policy to allow connections for the VPN interfaces, have the IPv6 input to allow basic IPv6 traffic. These are pretty much needed for IPv6 to work at all, as IPv6 is heavily using ICMPv6. Then we have some destination NAT from the output. So the traffic originating from this exact box is destination NATed like these rules show it, and this would be the place where we add destination NAT for traffic that's passing through our box. Forwarding could be used if we have a routing setup, and our output rules. In this case, they are only cosmetics, as we have the default policy accept. Okay, so far so good. You see the config, as always in firewalling. I haven't seen a firewalling system that isn't somewhat complicated after some time of use. It can get pretty hard to work with. I think the NFTables is pretty nice to work with, and especially if you're using Ansible or some other automation tool to provision it, you can abstract it and make it real transparent. If you need to debug your rule set in some way, you have one more tool that I want to introduce you to. It's the trace, NFTables trace. You can enter the trace on one shell, or let's enter on the shell and connect to the box using another shell. Let's enable trace for a single rule. What do we take? Okay. Let's use the let's use our nice little SSH management allow rule. We add a meta NF trace set1, so we activate NF trace. Sorry, may not be able to see it. Let's put it over here. Here it is. We add a meta NF trace set1, so we activate the trace for this rule. Basically what it does, it marks the traffic that is passing through this rule. So if you have a drop rule, this doesn't make that much sense. You can add a meta NF trace set1 at the beginning of a specific chain, for example. If you have some complex proxy setup or something like that, that could make sense for you. So all packets that are going through this chain or through this rule are marked, and you will see it on the monitor. So let's reload. And yes, you've seen there's pretty much data. Okay, what do we have here? It's basically the metadata of the packets. You see the verdict, so if it's accepted or denied because of the rule. And yeah, it's pretty nice to debug very complicated rule sets, but also make sure that only a very specific kind of traffic hits that meta NF trace set1, because you've seen I don't have any traffic here, but it's so overwhelming the amount of logs you get. But yeah, better to have than to need. Okay, that's pretty much it for this video. I hope I could show you some interesting information about NFTables, and yeah, I'm open to feedback. Please comment down below, and we'll see you in the next video, I guess. Have a nice day.